Does 6 times 9 equal 3 times 18? Take a look at the equation and decide if this is true. What is the relationship between the two sides of this equation? There's a way you can tell without multiplying. Write it down in your notebook what you think the relationship between these two equations are. You have solved equivalent problems in which the numbers were doubled and halves. One factor in the problem was doubled, and in order to make the same product, the other factor has to be cut in half. We're going to work on this idea some more and even go further to think about what would happen if one factor is tripled. Can you think of a story problem that would show that 6 times 9 equals 3 times 18? Start with the story problem of 6 times 9. Then change the situation to 3 times 18. Talk with your partner and come up with at least one story problem that makes sense. Put this in your journal. Here is the story problem I came up with. 6 clowns are juggling 9 apples in a circus. 3 of the clowns run off stage, so the remaining 3 clowns have to take their apples. Now the 3 clowns are juggling 18 apples. Do you notice how my 6 clowns was put into half by 3 clowns, so my 9 apples had to double to 18 apples. Both equations are equal to each other. Try it again on your paper of what would be equivalent to 10 times 4, thinking of the doubling and halving strategy. Write it in your journal what your equation is. Check with your partner to see if he came up with a different equation that is equivalent to 10 times 4. Now, do you think doubling and halving relationships in multiplication is true for other numbers? What if there were 12 clowns, each juggling 4 apples, and 4 of them went away? What if 10 books each had 4 chapters, and the author paired them up? Some of you are thinking that this idea about doubling and halving will always work in multiplication problems. You're going to work with a partner to show whether it does always work. But first, let's get a clear statement of what you mean by doubling and halving. What is the idea? The conjuncture we're trying to prove. Here's what we're trying to prove. If you multiply two numbers, you can divide one number in half and double the other number, and you will still get the same product. Create a representation that shows you're thinking about this conjuncture. It may be a picture, a diagram, or a model. The story problem you made up might give you an idea of what to draw. You may discuss this with your partner. So in your journal, write doubling and halving and show me what you think that means. Now I'd like you to get out your worksheet, Unit 7-1. And I would like you to work on that. together with your partner or by yourself. I would also like you to work on worksheet number 2, Unit 7. That one I would like you to do on your own and hand both of them in. Remember, being clear and concise is very important.